Hi Year 7, this is our third lesson for angle relationships. In this lesson we're going to look further at parallel lines. But before we move on, make sure you understand this. This is what we've learnt so far. In our first video we learnt about the conventions in geometry, like naming angles and lines and points, how to mark equal angles or equal line segments, and about parallel and perpendicular lines. In the last video we learnt all about angles at a point. We learnt about complementary and supplementary angles, angles in a revolution, and vertically opposite angles. Now we're going to start looking at parallel lines in more detail. And what I want you to do is learn how to construct a pair of parallel lines on a blank piece of paper. So you're going to need a ruler, a pencil, probably an eraser, and a pair of compasses. So what we're going to do is start by drawing a straight line and a point, which we're going to call point A. And that point is going to go above the parallel line. We want our parallel line to go through here. Okay, step 2, we're going to place a point on the line. It doesn't matter where it goes. And we're going to put our compass point on it and measure the distance to point A, like this. Using the same measurement, that means don't change the setting on your compass. Place your compass on the point on the line and draw a mark. That's called an arc on the line. So we put our compass here. So here's the point of the compass. And we're going to draw an arc here, like that. Now place your compass point on this new point, so here. And we're going to draw a large arc from this point up here, like that. Okay, last step. Now put your compass point on point A and draw a new arc across this one. So at no point have we changed the measurement on the compass. Finally, draw a line through the intersection of these two arcs and the point A. So in between these 2 points, like that. There's our parallel lines. Now you can rub out the pencil marks if you like, and we should put arrows on the lines to show that they are parallel. There they are. How'd you go? Here's an extension question for you. What type of four-sided shape did we use to create our parallel lines? Have a quick look at the diagram there. Remember, we used our compasses to make sure that these lengths were all the same. So what's a four-sided shape called that has 4 equal sides? It's not necessarily a square. It's a rhombus. Okay, so let's move on with some more theory. A line that cuts a pair of parallel lines is called a transversal line. It doesn't matter how it cuts it, as long as it cuts through those 2 lines. So I want you to draw a transversal line on your parallel lines. How many angles are formed? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 angles formed. Now I should mention, if you don't have a pair of compasses, just use lined paper to draw your parallel lines. You can still draw your transversal line and number the angles. Now we're going to use a protractor to measure each of the angles, and then we're going to write a statement summarizing what we've found. So lining our protractor up, I can measure this angle using this scale that starts at 0. So that's about 70 degrees. Obviously your angles are going to be different than mine. And measuring this angle over here, we're going to use this scale starting at 0 and coming all the way around, and it looks like 110 degrees. Turn your protractor upside down and you can measure the next 2. So have a go at doing that and put them into a table. Now if you don't have a protractor, what you can do is use Word. You can insert your scanned or photographed drawing, or you can use Word to draw a straight line, copy and paste it to make a pair of parallel lines, and then draw in a transversal line. Either way is fine. Then you need to go to Google Images and get a transparent background protractor, which is exactly what I used in this PowerPoint. And all you have to do is rotate the image to line up the protractor. So your angles will probably be different to mine, but what did you find? There's only 2, isn't there? They're either 70 degrees or 110 degrees. Is that what you got? What else can we say? In particular, what can we say about 70 degrees and 110 degrees? They're supplementary angles. They add to 180 degrees. Do yours add to 180 degrees? They should do if you've done it accurately. Okay, so here's a summarizing statement. Any two angles are either going to be equal to one another or they're going to add to 180 degrees. So there are three positions that have special names. That doesn't surprise you, does it? They are corresponding, alternate, and co-interior. Let's have a look at them. Here's the first one. Corresponding angles lie on the same side of a transversal line. One is inside the parallel lines and one is outside. So like these two. Can you see that they're both on the same side of the transversal line? One's inside the parallel lines and one's outside. Now corresponding angles are always equal to one another if they're on parallel lines. And we can see in this case that these are both obtuse. So remember back to our investigation, we either got an acute angle or an obtuse angle. So because these are both obtuse on our parallel lines, they're going to be equal to one another. They make an F shape. Some students like to remember these letters so that they can remember the names. That's up to you if you want to do that. Now, there are 4 pairs of corresponding angles, so that's not the only one. Now, if I go back to numbering the angles, I've shown you angle 4 and 8. So I'm wondering whether you can tell me what the other 3 pairs of corresponding angles are. Here's the answers. So the first one is 3 and 7. These are corresponding angles. And there's the F shape. It's back the front, but it's still an F. Another one is 2 and 6. 2 and 6. There's the F. And then finally there's 1 and 5. 1 and 5. And there's the F there. Here's our second one. Alternate angles lie inside the parallel lines but on alternate sides of the transversal. Like these two. Okay, they're inside the parallel lines, can you see that? But they're on opposite sides of the transversal line. Okay, they're always equal to one another as well. In this case, they're both the acute angles, and they make a Z shape. Okay, there are only 2 pairs of alternate angles. So I showed you angles 3 and 5. What's the other pair? It's 4 and 6. This one and this one. And there's the Z shape. It's a pretty wonky Z. It's back the front and it looks funny, but it's still a Z. Here's the third one. Co-interior angles lie inside the parallel lines on the same side of the transversal. So here's an example. Now do you notice something curious there? I've marked them differently. Do you see that? I've marked this one with a single arc and this one with a double arc. Why do you think I've done that? It's because they're not equal. They're supplementary. Okay, here we've got an obtuse angle and here we've got an acute one, so they can't be equal. They make a C shape, so you can use that to remember it if you want to. And there are 2 pairs of co-interior angles. So I've given you 4 and 5. What's the other pair? It's 3 and 6. There they are there. And here's the C shape. Back the front, but it's still a C. So you're probably a little overwhelmed with how many new words that you've had to learn. Let's just go through all the ones that we've learnt so far. So complementary, they add to 90 degrees. Supplementary add to 180 degrees. A revolution is 360. Vertically opposite, remember those are the angles that make an X shape. We learnt what a transversal line is. It cuts through parallel lines. And then here are our 3 relationships that we just learned for parallel lines. Corresponding angles, they make the F shape. Alternate angles make the Z shape. And co-interior angles make the C shape. Okay, that's enough for today. In our next lesson, we're going to look further at parallel line relationships and look at how we solve geometrical problems involving them.